Hi, on this second tutorial we are going to learn how to understand the code that we can write on a script. Let's open our last project. A script needs to be on an object to run. If it's not inside an object, it will not run. If I remove this script from here, remove component, let's clear the console. If I hit play, this script is not working because it's not there and it doesn't do anything. These components over here, this inspector shows the components of the selected object. For example, I will add here quickly a cube. Now we have a cube, and the cube has some components different from the camera components. Okay, one that you will see that is common to every object is the transform. Every object needs to exist in space inside the scene, so every object, even an empty object, will have at least a transform. So the transform is that component that is there even if you don't need to specify numbers over here. After this you have other components depending on the object you are using here. For example, the camera, the main camera object, it's called main camera. I can change the name, my camera. This doesn't change how it works, just change the name. And this camera object has the transform component, the camera component. Well, this is the real component that really make this thing work like a camera. And then we have here another one, which is the audio listener, that doesn't have any options and doesn't open. So this is just telling Unity that all the sound should be processed from this point, like your ears are in this point. So you can only have one audio listener per session, per scene. You cannot have two cameras with two audio listeners. You can have two cameras, but you cannot have two audio listeners. So this is the point where the sound reaches and is processed to send to the headphones or the speakers or whatever. So this camera object will have three components: the transform, the camera, and the audio listener. Technically, these are just scripts like any other script you can do, but this comes with Unity already. So this camera component has some properties here that you can change. You can change manually here in the inspector. You can change by script from other script. Let's see the cube. For example, the cube has the transform. Of course, it needs to exist in space. It needs to have a rotation and it needs to have a scale. Then you have the cube, the mesh filter. This is a component that will somehow put the mesh, and the mesh is the 3D object inside the Unity, and then a mesh render. It will pick up that mesh and will add some properties to it so you can see it. If the mesh render is not here, you only see the mesh. You cannot see anything. If you select it, you only see these lines, but if you render it, you can see in the camera, and it will render using these properties. Okay, and then you have here another component, which is a box collider, and this will be used to calculate where the box is physically and how it will interact with other physical objects. So this is like it's not very advanced, but this is more advanced thing, and we will reach here at some point. But for now, we just need to understand that an object has components, and these components belong to Unity, or you can make your own components by scripting. For example, my hello script can be seen as a component for this camera, so I can just drag the hello script here, or I can drag the script there, same thing, and I will add the hello script to my camera. So now it works as a component. I can have properties here that changes the behavior of the camera. Okay. In this case, it doesn't do anything unless printing hello in the console. So, if I can add scripts, I will use scripts to control my game, to control my characters, and to control the behavior of my game. But to do that, I need to understand how to write a script and which kind of things I can do with code. To edit a script, you just click twice on the script here. You create a script. Let's see, for example, let's create a new one. Script. I will create this inside the scripts folder. Right click, create C# script. I will change the name. I will click enter, and this will create me a problem. Now I need to change the name because I press on enter before changing the name. So now the name is, I want to call it movement. Enter. No, I like more this name. And this is a very common error that happened with beginners in Unity. So now the movement script is here. I want my cube to move, so I will drag this movement inside the cube, and this will pop up. Can't add the script. Can't add script component movement because the script class cannot be found. Make sure that there are no compiling errors, blah 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 blah. This means what? This means that inside the movement file you should have a movement class. Okay. And as you can see here, we have a class, a public class, but this class is called new behavior script because I changed the name after. Okay. So movement inside one file, but at least one of the movement, it's okay. Yeah, no problem. The cube has the movement script over here. Doesn't have any options. I didn't program anything yet, but it's here, so it's running. So this is one of the first problems you encounter. You create a script, you forget to change the name, you click on enter, and then you change the name because you want to name it something, and then it doesn't work. It doesn't work because the class doesn't have that name. Okay. These are libraries that have functions inside, and if we say using system collections, we are using those functions that you can call for them in here. These are functions from the system, these are functions from the Unity engine, and there are others that we will use eventually, but when we need them, we add them here. After that, we have this box. Imagine this is a box, and this public class movement is a mono behavior class. Public because you can access it from other places, not just from inside this class. And this class is, let's say, is your script is this class. So everything it will happen, it's inside these curly brackets here. Okay. So you have a box, and here you have another box, and here you have another box. So this box is inside the bigger box here. So this box is inside this one, and this one is also inside that one. Okay. And you can see these as lines. Let's say this will happen in this order. Okay. And here this will happen in this order. So anything you write inside this box will happen this line first, then this one, then this one, then this one, all of them, and then Same thing to the other boxes, and you can create your own boxes, and you have another type of boxes that are already created. We'll get to there in a bit, but for now we just have these two, the start and the update. So these are functions. You can imagine them as a box, but these are functions. This is what is going to happen when you run the script. And you have here the start function and the update function. As you can see by this comment, start is called before the first frame update. And it's called just once. And it's called just once. This represents a comment. Anything that I write after these two bars, I can write whatever it needs to be written here. This is information for me as a human to understand what is happening. This is not for the computer to read, this is for the human that is programming to read. So what is written here is not very important for the computer. You can have mistakes here, no problem. If you don't have this, the computer will interpret this as code and will try to understand what you are saying here. So this will throw you an error because it will say just that does not exist, whatever. Okay. So if it's not a comment, it's code, and it's viable code. Okay. We have functions, we have classes, and then we have statements and variables. Okay. I will write here a statement, for example. Print hello again. Okay. And the print command, let's say like this, it has some arguments. It needs to have something to print, and this something to print is written inside this parenthesis. Because it's a word, words need to be inside this symbol that I don't say the name in English. I don't know the name in English, sorry. So this is a word. This is the argument of this command. And to finish the statement, you use a semicolon. So print this over with this line. Next line. And then we can have another line with another statement. Print hello you too. And then this is another statement. So this is another line of code. These are two lines of code. One line of code, another line of code. If I save this and I go to Unity, I hope I don't have errors. Let's see if I don't have any error. I guess not. I will hit play and this will play hello again and hello you too. Oh, and it printed hello. Why? I didn't write any hello over here. Where is the hello come from? Well, the hello comes from the other script that is in the camera. Okay, so don't forget that you can have 200 scripts printing here, and you need to understand where the printing is coming from. If you click on this thing, hello again, even if this is an error, hello again comes from, it says here, comes from asset scripts movement CS line 11. So this is the script and the line where this thing comes from. It could be an error. And this comes from line 12. Let's see if it matches. Yes, line 11, line 12. And then we have this hello that comes from the hello C# script, line 10. So it comes from this one. Let's see. Let's open the hello. Yes, the hello script prints from line number 10. But I don't want this print. This is already working. I know this is working. I don't need this print anymore. So I'll just remove this. I can delete this line and it doesn't print anymore. But I don't know if I will need this again in the future when I will test something else. So sometimes I don't want to delete code. I want just to remove it from execution. So I can just comment. So comments also work to disable parts of code. In this case, I'm disabling this line. I just double slash here, save, and it doesn't print that hello anymore unless I remove those. So let's go on Unity. I should stop playing before, because now it's throwing me an error, because I shouldn't change the script while playing. So now I will play again, and it will only print the hello again and hello you2 from the other script. Okay, the camera script is there, it's working, but that specific line it's not printing because it's commented. Okay, if I want to comment more than one line, for example here I want to comment both print, I can, well, I need to click on 4 keys. So 1, 2, 3, 4 is the same thing. But if it's more than 3 lines, you can do slash asterisk asterisk slash, and it will comment this group. So I can have here as many lines as I need. This is this represents this as a group to be commented. Okay. So this is the basics of commenting, double slash or group. Let's remove these comments. We have this printing, print hello again and hello you2. But as you can see, our game is running. Let's run the game again. Our game is running, but it prints hello again once and prints hello again, hello you2 once. So if our game is running, is currently running, I can see here stats, 300 frames per second, almost 400, so nice. If our game is running right now, why is not keeping on printing? Well, it's not printing because we do this inside the start function. Start function happens before the game starts. So you add the script to an object when you hit play. When that object it's enabled, the start function will happen once, and then the update function, after the start function, the update function will be called once per frame. This means that in this case it will be called, how many frames per second did I have? 400 frames per second, so this will be called 400 times per second. Okay, whatever you have here will happen 300 times per second, 100 times per second, 25 times per second. It depends on the computer, of course. So let's print here, print I'm a new frame. Oh, I forgot here this thing. I don't need this anymore. This is hello again. I will change to before first frame. I will delete this one, and then in the update function I will print I'm a new frame. So save, let's go to Unity and let's play this and see what happens. What's going to happen is every frame Unity will write this. It's printing 600 and whatever times per second. Okay, I will pause. I really don't need to pause. I can stop. Stop is removing the play. You don't have a stop button. And I can go here, see what happened, and as you can see I have a lot of lines now. And the first one is before the first frame, and then every frame computer printed I'm a new frame, I'm a new frame, I'm a new frame. And this is the basic of these two functions. Start will happen before the game starts to run, and as soon as this is finished on all scripts, game starts running by updating every frame. Okay, everything you do here will update. So if you have here a line to move an object, every frame the object will move a little bit. If you have here a line to check for a key, every frame the computer will see if you are pressing a key. And if you press a key, computer will do something with that. I don't know. It depends on what you program here. Okay. So this is the basics of a script. The class is everything, is the script itself. Then you have inside the movement, you have the start function and the update function. The start function happens once in the beginning, update every frame. You see that the start function has this parenthesis here and it has this void over here. This means that when the start happens, it will return nothing. It doesn't return anything. Just happen whatever is inside here and doesn't return anything. You need to return things when you call for another function inside your update, for example. We can do an example in a bit. So this is the name. If you create your own names, you can have your own functions. You need to be very careful not to use names that Unity already uses, because it will throw you an error that is very ambiguous and is very difficult to trace. Because the error doesn't say something like, oh, this is a Unity function, don't create another one with the same name. It doesn't tell you this directly. You need to get there by many hours of Googling. And this parenthesis is to hold some parameters. In this case, start doesn't have any parameter, update doesn't have any parameter, so this is empty. But if this has some parameters, these parameters can be accessed inside the function, and you use the parameters to send information there. We will use this later, so don't worry about it. For now, just ignore this. Just make note of the structure. You have the return, the name, the parameters, and then open brackets and close brackets, and what is inside this box will happen when this is called. This is called once in the beginning, this is called every frame. Let's try to do something more interesting than just printing. And let's remove this. No, I will not remove, sorry. No, let's comment here. So the start function doesn't do anything. Sometimes we don't need to start anything, just need to run it, whatever we need to run. For example, we use the start function to set up some variables for our characters. For example, how many lives the character starts with, how many ammo it has, the speed of the engine, or whatever it needs to be started. Okay, when it starts with everything that we write here. So let's have a calculation here. 3 plus 5. This will print 3 plus 5, or this will print the result of 3 plus 5. Because this is written here directly, the computer will calculate these numbers, this equation, if you want to look at it that way. So let's save, let's go to Unity, and let's run it. 5 plus 3, or 3 plus 5, it's equal to 8. And it's running, is spitting 8 every frame. If I want this as a text, this is a word, I can just, if I do this, this is seen as a word, not as a calculation. It will write 3 plus 5, not 8. as you can see. We have two kinds of data types. Okay, we have value data types and reference data types. The value data types are simple things like numbers and words, and reference data types are, for example, components. I can use transform as a reference to talk to the transform, but then I will need a number to write the number there. Okay, so let's start with the simple ones. An integer, you call it like this, you give it a name, for example, lives equals 4. So I'm declaring an int with this name, and I'm setting the number when I declare the variable. This is a variable. This is a box where I can store some information. Okay. So now if I need to make some calculations with that, I can write here. Let's remove the string and let's make the calculation. I can write here lives -1, for example. When the player loses 1 life, this will happen. Okay? We calculate this, for example. So this is a number. And I can only subtract, add, or whatever I need to do mathematically ints with other ints. Okay? I cannot do this. This will throw me 2 errors, but I cannot do this because lives are integers, are whole numbers, not numbers with decimal parts. Okay, so if I want to use a number with decimal parts, I need to use floats. Let's say, for example, speed. The speed will be equal to 3f. If you don't have this here, it will throw you an error. You can also do this. For the computer, this is 4.0. This is the same as this. Okay. But because it's a float, you can go here and add more detail to the number. Then you have, let's keep it simple, booleans. What is a boolean? Boolean is a variable that has only 2 states, is true or is false. Can run equals to false. Okay, so now the variable can run is false. So it can be false or can be true. And this can be used to turn on or turn off some parts of our script, for example. Try to use names that you, human, can read, so you know what is happening. Keep the things human if you can. I will talk about another one, which is strings. String name equals, and now because the string needs to be inside this, for example, these are boxes. They have names so you can identify them, but these are boxes that store information. You can only have one box with the same name. You cannot have 2 different boxes with the same name. And you use these boxes to store the information, so when you are programming your behaviors, you change the value inside here instead of hard code the numbers. Because if you hard code, you cannot change them. But if you use a box, you can change what is inside the box in real time, so your game can evolve in time. So in this case, I don't know, maybe this is a running game, athletic running game, and the Pedro player will run at this speed and it has 4 lives. I don't know, you know. So this can be used to store information that we can use later to make the thing happen. Okay, so let's apply this to our game and let's write here something in the console with this information. So the space, close this, plus will not add mathematically, it will add in front of. Okay, so print the name. Okay, the can we will change this later. Can run at and then here we put the name, the variable speed. And here we say kilometers per hour. So we are constructing a sentence with this plus sign here. We are adding this string plus another string. Why? But this doesn't have those signs around it. Oh, but this is a string. It has here. Okay, so the Pedro can run at, and this is a number. So this is a problem. Speed 4 point whatever kilometers per hour. If we save this, the computer will throw us an error because I cannot print a number. I can print words. Okay. I can print words, but I cannot print numbers. Let's see what happened if I run the script. It throw me some warnings here, but probably it will crash. No? Oh, they changed this. I don't know why, but this should throw me an error. I should have to transform this in a string before I do this. Anyway, it's no longer a problem, so I guess it's okay. Let's see, the number is touching kilometers per hour, so I should add here the space. So this is just for showing you too that I can use my variables to add information that can be changed later. So this is coded. I don't need to touch this sentence anymore because I can change the speed and the name, and the sentence will be correct every time I do that. I don't need to hard code every name or every speed possible. Okay. But when I'm here, I cannot change the speed. I cannot change the name. Well, but I want to. How can I change those numbers? If you do this to declare a variable, by default, this variable is private. It's like this: private string, copy, paste. This is what's happening by default. If you don't write anything, it's private. But you can make them public. For example, if I say public here, and public here, save. Now I will be able to change those. And where I can change those? I can change those variables from other scripts. Oh, I'm in the wrong script, sorry. Cube. So here I have my variables. I have the speed variable, I have the name variable. Okay, so I can change them here in the inspector, or I can change them through other scripts. Okay, if they are private, I can only change them inside the scope they are. In this case, they are declared inside the class, but before any function, so they are available for all the class. If I declare this inside start, They are only available to the start function, and if I declare them here, they are only available for the update function. So these should be declared here, so you can use it inside the start, inside the update, or whatever functions you need to use those variables. Okay. So here, if I run the script, I have here the number and I have here the name. If I run the script, now I can change these numbers and the game will update. For example, the Pedro can run at 4.25, but I can say, no, it's not Pedro, it's Raul. And now it says the Raul can run at 4.25. No, it can run faster. So 7. See, it updates the thing that is happening inside the game. Of course, when you are playing the game, you are not touching in the inspector. It doesn't exist inspector inside the exported game, so you cannot change this in playing mode, at least in the final version. So don't expect this to be your interface. If you want to change the numbers, you need to create the interface before to change the numbers. But the main thing here is I want to, and I need to have a space here. I want to do something with this information. I need to change the information. Can I set the information and if I don't need to change the information, it can be private. If I need to change the information from other scripts or from the inspector, it needs to go public. Okay, so we have a name and the speed. Let's try to make something real with these numbers. Okay, let's put the cube moving at this speed, just to test it. Okay, I will explain this in other tutorials, but for now let's just add here some lines to make it move. Well, but I'm a beginner. I really don't understand how to make the thing move. How do I do it? It's the first time I'm seeing this, so how do I know which commands I need to use? Well, you go to the internet. Not now. You go to the internet and you ask, for example, exactly what you need to do. Let's say Unity move cube. Let's see what happens. And if you scroll a little bit, you will find two websites that you can find a lot of things related with Unity that are, let's say, correct. Many of them have, but Unity docs, Unity is documentation of Unity, so what you have here is the source of the knowledge about Unity. So this will help you move throwers, numbers, whatever needs to be done. It explains here the vector3 move throwers. This is a command. And then you also have the answersunity.com, which is a site where you can ask questions and someone will answer, but many times the answer is already there. How to move a cube. So you click here and someone just asked that, and it has some replies here, and you can try to find the code and you can try to understand what does the code do and if it applies to your thing. Okay, so in this case, let's see. So I just got Unity. I want to make a cube move. I got a plane and a cube, and coding I need to do. Any coding I need to do. Also, can anyone tell me why it says the peripheral? So the guy is having an error. Let's see what it has here. It has a variable, a public variable. Oh, this variable is not a value. This is a reference type variable that calls for the game object directly, not a number. So we need to tell the script, oh, there is a cube. Okay, the cube, it's here. Let's copy this. If you really want to learn, you should write this, not copy. So let's add here the variable. So variables can be numbers, can be floats, can be booleans, can be strings, can be other value things, but also can be objects, can be transforms, it can be mesh renders, it can be box colliders, it can be cameras, it can be audio listeners. You can make this can be accessed as a variable, and you can access to all of these parameters. Okay, so in this case I'm calling a game object called cube. I'm not specifying anything else, I'm just saying game object, so I'm referring to this thing over here. Okay, so the guy has that. Let's see, in the update, so every frame cube transforms position, blah 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 blah. Copy paste. I will explain this code in a bit. So every frame it does this. Okay, so first thing, game object cube. How Unity knows that this cube is the cube? This is just a name, it's not the object. So maybe it is because it has the same name. Let's change the name, see what happens. So game object cube, and then we are saying cube dot transform dot position, and then calculations. This dot means that something inside this there is another property, and this dot means that inside this property, that can be a list of properties, it has more properties, or this can be a struct with several numbers. This can be another component which has another variables, etc, etc. So this case, this is referring to the cube, which has a transform, and that transform has a position, and that position can be altered. Okay, this is what this point means, this dot means. So if I save this, you go to Unity, let's see the errors it's going to throw us. No errors. Let's hit play and see what happens. So the script is here. Let's hit play. And then we have errors. Of course we have errors because computer doesn't know what cube is. See? The variable cube of movement has not been assigned, so it doesn't know what it is, the cube that you say, oh, there's a cube here. And if you go here on the scripts inside the inspector, because cube is public, you can see there, you see cube, none game object, so the cube doesn't know which cube it is. This is a little bit stupid, but this script is inside the cube but doesn't recognize its parent as the cube, so we can force it to do it, or you can just drag the cube there because it's a variable, so variable takes values, and this kind of value is a game object, so I can drag a game object there. So now the script knows which cube I'm referring to. I'm referring to that cube, that box, that cube that is called box. So now here, if I hit play, it will not throw an error anymore, and the cube will start moving 4.25 meters per frame, I guess. So it should write super fast. Yeah, disappeared. Because cube transform position is being incremented by this value. And this value, this is a vector 3, is a variable that has 3 numbers inside. X, Y, and Z is a vector. And it's 1 in the x-axis, 0 in y-axis, and 0 in z-axis. So it will increment 1 meter per frame. Okay, 1 meter per frame. If I want this to increment in meters per second, I need to multiply this by time, which is a command that handles time, but I want a specific type of time, so dot delta time. Oh, it's not like this. Delta time. Okay. The code is case sensitive. If this time is like this, is wrong, doesn't exist. Okay. Time, delta time. This will multiply the speed by the frame time, and it will run at speed per second. So this will be 1 meter per second because of this. So if I save this, if you don't understand this, no problem, just memorize. If it has movement, it needs this, and you will understand it later with experience. No errors, I guess. And if I hit play now, I will remove the game window from here, because when I hit play, it goes automatically to this window, but I want to see the scene window, so I will remove the game window. I will put it here because I don't really need to see what the camera is seeing, at least not for now. Let's see, it doesn't have, no, okay. If I hit play, this will move 1 square per second, 1 meter per second. Oh, this is 10 meters. Okay, 1 meter per second. Okay. So if I change the speed now, let's say 100, 1000, it doesn't change. So what's happening? Well, we are changing the value, but we are not applying the value to the movement. See, the new vector that will change the direction and the speed in each axis is not using our speed, is using 1. It's a hard-coded speed. It doesn't change, it's always 1. Every frame will be 1. So instead of 1, let's write here speed. Save. And now we can change the speed of this movement. This transform position increments by this per frame, which will be those meters per second. Because time delta time is time per second. That's why it's these meters per second. So if I write 1 as it was, it will move the same. But if I increase this, I will increase. I can click and drag. It's faster, see? And I can go 0. If I increment the speed by 0, it doesn't move. It's incrementing the speed, but it's incrementing 0, so it doesn't go anywhere. So I can add negative numbers and it goes one side, add positive numbers, goes the other side. See? Very funny. Well, but I will not play with the mouse in the inspector. Doesn't make sense. I want to use my keys. Let's use the arrows to do it. This is a speed. The speed is a fixed number. We can change it, but it's fixed in 4 point whatever. But now we need to multiply this by the direction. So we can technically this speed can be, for example, times 1, so it goes to the right, or times -1 and it goes to the left, or if it's times 0 it doesn't go anywhere, right? It makes sense. So let's say times direction, and this direction needs to be a float because this number is a float, so we can only multiply floats by floats. The vector is expecting a float. This is a number, you know. The vector has 3 variables, 3 parameters, x, y, and z. They are separated by a comma, so this is a number. These are technically 2 numbers, but vector only sees the result of this equation. So we just need to say, for example here, direction equals 1. This is a float. We need to declare this as a float. Save, and it goes to the right at that speed, because 1 times 4.25 will be 4.25, so it will respect that speed anyway. If I say here -1, direction is -1, it goes to the left, and if I say here direction equals 0, it's stopped. So this works. But now let's use some code to use the keys to change this direction number. Okay, so every frame direction is set to 0, and then we will check our keys. If it's the left key, this will be -1. If it's the right key, this will be 1. Okay, but how do I check the keys? Once again, if you don't know how to do it, go to the Google website and search Unity using keys. Oh, we have here the documentation of Unity Scripting API, input get key. By the name get key, maybe is this one. Let's see if it's, oh, but I have here a different one, get key down. 2 codes to get keys. Let's see. So if we open this documentation, we'll get to this website, and this has the command .get key. So input will input from many sources like joysticks, keyboards, mouse, touch screens, whatever it is, and then you have specific command you want to run, in this case get key, and this is a declaration. It's a public static boolean, so it's on or off. It will return on or off, 0 or 1, and get key is expecting the name, and this name is the name of the key. If you go here to the example, you have if input get key up, print the arrow key is held down. Oh, this is exactly what we need, so let's just copy this. Copy. So, but instead of printing, we will change the number. Yes. So paste. If input get key, let's say left, which is the left arrow, instead of printing, we will change the number. Direction equals -1. I don't need to declare again. This needs to be declared once. So when I do this, float whatever name, I'm declaring the variable, but now I can use the variable directly because it already exists. Okay, I cannot declare 2 times the same variable. So if input get key, input command dot get key to get the keyboard, it's expecting the name is a string, so left. If I want to use the R key, I just do this. Okay, so left. These brackets belong to the get key, and these brackets belong to the if. the if command will test this, whatever is inside the brackets, and if it's true, this happens. If it's not true, this not happen. Okay, so this will only happen if input get key left is equal to true. Okay, this is exactly what is there. If input get key left is equal to true, and we know that key left gives us a boolean because it says here boolean get key. So when you press the key, you have a true. If you don't press the key, you have a false. Which key? This key. Okay. So if input get key left is true, this happens. For example, imagine that is equal to 65. This will throw us an error because this is not giving us a number. This will give us a boolean and is testing against a number, so it will say like, I cannot see if a boolean is 65 because a boolean is true or false, you know. So if this is true, direction -1, and you can repeat this to the other side. If right is true, direction is 1. Okay. We can change here the name. Let's see, X direction. Let's use this name. X direction, X direction, X direction. If you click on a variable, you see it selects all the names that you are supposed to use the same variable. So if you click here and, for example, like this, if you click here and anything else gets gray, it's because you have a typo. Oh, you are missing here one letter. Now this is a variable that is declared, it appears like this. Okay, so now I'm multiplying the speed with the X direction, and the X direction at the beginning of the frame is 0, but then it can be changed to -1 or 1 if you press the key. Okay, let's see if it works. It didn't give us any error. The yellow warnings are not errors, are just warnings. The errors are red. Let's clear. Let's hit play. And let's increase the speed, for example 5, be faster. And let's hit play. It's running because Pedro can run at 5 kilometers per hour. Can, but it's not. Click here on game window so you can play, and then use the arrows. See, now it's moving. So this is the basics of having variables and use the variables to control things inside our script. Our script will control whatever you need to be controlled. In this case, it's controlling the movement of this box, and we can play the game by using the arrows. In this case, the game has no purpose unless moving left and right, and that's it. Okay, so this first exercise is just to script this, copy this, write with your own hands, don't copy, write this code, get errors, try to find why you have errors, correct the errors, and get used to this syntax, these forms, this kind of thing. Okay, functions, they have a return value, a return type, they have the name, and they have the parentheses for parameters. In this case is empty, and they have open brackets and close brackets to have whatever it needs to be inside to run. Okay, this is a declaration of a variable, so these are variables. In this case is a float variable with this name and with this value. This will happen every frame. That's why when you don't click anything, it returns to 0. For example, if this is up here, it doesn't stop moving because nothing is saying to go 0. Okay. Then this is a conditional. I don't know if I can say statement here. I guess I cannot say statement. This if command will test whatever is inside the brackets, and if it's true, it will run whatever is inside the if. These curly brackets here open and closes whatever is inside the if. You can have multiple things here. Left, for example. So this allows you to have multiple things happen when this is true. And this is a statement. The print is a statement. The x direction equals 1 is a statement, and you need to close the statements with the semicolon. Right. And let's print the name, and let's cut from here and paste from here. Oh, there is another way of doing this. If you just want to move lines, you just have the cursor on top of the line. You press on Alt and just go down and up, and it will change much faster sometimes. So imagine, oh, I don't want this inside the update, I want up there. So much easier to do this instead of copy, delete, paste, whatever I need to do. Okay. What is happening inside this update? We are declaring the direction 0, so it doesn't move. After that, we test if we press on left. If this is true, if we press on left, we change the direction to -1 and we print left. If we press on the right key, we change direction to the right and we print right. And then we increment this is the same thing as this. This is the same thing. It's a shorter way of doing this. Cube is equal to itself plus the movement. Okay, so cube position is equal to current cube position. Right? So it's equal to cube position plus whatever it needs to be calculated. And one shorter way of doing this is plus equal plus equal. This is a shorter way of writing all of those things. As the if something is equal to true, by default is testing if it's true. So you really don't need this part. You just need this part if you are testing something that is different from true. For example, false. This you need to write. But by default it tests the true. So this is enough. You can do this, but you don't need to do this. Okay? And I'm saying this because sometimes you find the code like this, and you may ask, well, but this is not testing anything. Where is the equal sign? Just for you to be aware of this reality. What's happening here? You declare 0 as direction. If you press left, you declare now, you change direction to -1. If you press on right, you change direction to 1, and then you apply that, you multiply that direction with speed, and then you apply the speed to the x position of a vector, and that vector will change the position variable inside the transform, which is this over here. You see, you have the transform dot position dot 3 numbers. Okay, so you are changing this number. Technically, when you move, you are changing this number. If I hit play, you will see this number moving, incrementing or decrementing. See, left, right. See, the number is changing. Why? Because this script is talking to the position to, is adding a new vector to the in the position variable inside the transform inside the cube, and the cube, it's a game object, and the game object is set here, and this game object is the box. It is that game object. So everything is related and everything has a path from the beginning to the end. You don't say move the square or move the cube and by default the Unity knows what you are talking about. No, you need to point to everything. So for this first exercise, just copy this script over here, write this with your own hands, and if you want a challenge, I will let here a challenge. Easy one, a very easy one. Make the cube go up and down. Nice, very nice. Second challenge, make the vertical speed faster than the horizontal speed. And don't allow the cube to go outside of the screen. Only with variables. You can do this only with simple variables. You don't need to do any special thing to do this. Just technically you have the knowledge to do it. Let's see how much can you add to this script, and let's see if you can solve this. This is easy, this is medium, this is hard. Okay, so this is the challenge for these exercises, and that's it. See you on the next one.